electrical discharge machining. So in electrical discharge machining, the tool and the workpiece will be connected to a power supply. The tool and the workpiece will be connected to a power supply unit through a RLC circuit. Okay, there will be a RLC circuit which will be connected to the power supply. So the RLC circuit in electricity is working like a flywheel in a mechanical system. It will work as a flywheel. It will work as a flywheel in a mechanical system. So during 75 to 85% of the cycle time duration, the energy supplied by the power supply unit will be stored, and during remaining will be stored. Okay, for the 75 to 85% of the cycle time duration, the energy supplied by the power cycle will be stored. Okay, and the remaining 50 to 25% of the cycle time duration, the energy supplied by the power supply unit will be discharged spontaneously. Okay, so for the 75 to 85%, your energy will be stored, and for the remaining 50 to 25% time duration, the energy supplied by the power supply unit will be discharged spontaneously. So due to this spontaneous discharge, wherever the gap is present in the circuit, okay, so due to the spontaneous discharge, wherever the gap is present in the circuit, at such places the spark will be taking place. Okay, remember this thing very carefully. Because of the spontaneous discharge only, wherever the gap is present, in all these gaps the sparks will generate. Okay, so by maintaining the intentional gap between the tip of the tool and the workpiece, the spark is produced between the tool and the workpiece. I naturally spark will produced between the tool and the workpiece only. Okay, so this intentional gap between the tip of the tool and the workpiece, spark will be produced. Okay, so because of the sparking at very high temperatures are induced, and due to this, the workpiece is getting melting and evaporating. So because of this spark, the workpiece will get melted and evaporated. That's all. That's all. That's the point to be conveyed. Okay, so when very high temperatures are induced between the tool and the workpiece, the chance of burning of metal is also very high. So to avoid this, the sparking zone will be immersed in a dielectric fluid. Okay, so here the medium for electrical discharge machining is dielectric fluid. Remember, first there will be a tool and the workpiece. So before that, I told you that the tool and the workpiece will be connected to a power supply called RLC. This RLC circuit in electricity is a working line flywheel like a mechanical system. So during the 75 to 85% of the cycle time duration, the energy will be supplied by the power supply unit, and this unit will be stored. Okay, so the remaining 15 to 25% of the cycle duration, the energy supplied by the power supply unit will be discharged spontaneously. So due to this spontaneity, there will be due to the spontaneous discharge, wherever the gap is present in the circuit, at such places the sparking will take place. Okay, so this intentional gap between the tip of the tool and the workpiece, the spark will be produced between them. So because of this sparking, at because of this sparking of very high temperature are induced, and due to this, the workpiece will get melted and evaporated. Okay, so when very high temperatures are induced between the tool and the workpiece, the chance of burning of metal will be high. This should not happen. Okay, so in order to avoid this burning of metal, the sparking zone will be immersed in a dielectric fluid. So this is the explanation for why they have used this dielectric fluid in the electrical discharge machining. Okay, so this will be the medium for you. So due to this immersion, the pressure at the spark zone will be reduced, and hence the efficiency of evaporation will increase. Okay, so as the pressure falls, sometimes it may fall below the partial pressure of water vapor in atmosphere, so that cavitation will be occurring. So here naturally here the pressure will fall. Okay, so the if the pressure falls below the partial pressure of water vapor in the if natural thing is this only. If the pressure falls below partial pressure, it will lead to cavitation. If P is less than PV, okay, that is P is the normal pressure and PV is a partial pressure. So if that atmospheric pressure is if the atmospheric pressure is less than partial pressure, here cavitation will naturally occur. Okay, so based on the above, the mechanism by which the material removal is taking place is melting and evaporating, associated with cavitation or spark corrosion, and cavitation or corrosive reaction. Okay, then Mechanism is simple. Material removal is taking place by melting and evaporating. It is associated with cavitation or spark erosion and cavitation or corrosive reaction. Just remember this. Okay. So next one will be first. I told you all those points to be considered for each process, right? First one, you have completed the mechanism of tool removal, and I have explained why they have used this mechanism also. So make a note of it. For mechanism, it is evaporation and melting and evaporation, and it is also associated with cavitation or spark erosion and cavitation or corrosive reaction. So this is a mechanism.